Okay, so I attempted to draw a hypercube, but it was a hypercube disaster. So we'll just do it. You can imagine you make a square by sliding a side of length 1 up.
Yeah.
You make a cube by sliding a square of length 1 across, like this.
And then we need another direction to slide our cube.
So we take our cube and slide it, and that makes a hypercube. But if I try to draw in all the connections,
It's going to be a little blurry.
yeah, it's hard. But so we learned that the diagonal of the square was root 2. The diagonal of the cube, connecting opposite corners of the cube, was
Root 3.
root 3.
So I think the diagonal connecting the opposite corners of the hypercube would be root 4.
Yeah, and so the question is just where are those opposite corners? So it's a little hard to see where that could be.
Well, I think the root 3 might be involved.
Yeah, I think the root 3 might be involved too. So we're sliding the cube this way. So we've got to try to find what, in a sense, is the opposite corner of that, because it goes root 2, root 3. There's the opposite corner in the square. There's the farthest away corner in the cube.
Wouldn't it be like this corner if we put the hypercube in?
Yeah, it is going to be this corner. And it's weird how this slides, because what you're going to find is that you have this root 3 hiding in a triangle somewhere. And so we're going to have a triangle that has a height of 1, say?
Yep.
Height of 1, and this is root 3.
So it's sort of like it comes off and goes in.
Yeah.
That's tricky to imagine.
It is very tricky to imagine. But if I have 1 root 3, what's this going to be?
That would be root 4, 2.
2. So I have 1 squared plus root 3 squared equals x squared.
And
1 plus 3 is 4.
And this is a right triangle.
Right, it's a right triangle. 1 plus 3 is 4. So this is 2.
And this is a 30, 60, 90 triangle.
Hey, how about that for a surprise? Inside of a hypercube, you have a 30, 60, 90 triangle when you draw the longest diagonal, even though it's very hard to see where that could be. So, very interesting. That was an interesting observation you had about how root 3 might show up in a cube, since root 2 shows up in a square, and then root 4 shows up in a hypercube. Pretty neat, right?
Yep.
All right, good job. Good job today, huh?